Welcome to the first lecture of on fluid mechanics. So this is the first unit syllabus. Okay. Yeah. So here in the first unit today we are going to discuss about the basic introduction to fluid mechanics, and we will study the fluid properties, some of the fluid properties. Like today we are going to discuss about density, specific weight, specific volume and specific gravity, and we will try to solve few examples on basic fluid properties. First, before going to the subject, first we try to understand what is solid and fluids. So the solids and fluids are classified based on the molecular space between the fluid particles. So what is solid? If the molecular space between the fluid particles is almost zero, there is no molecular space between the fluid particles, then you can call it as a solid. So what about the fluids? Fluids are two types, you can say liquids and gases. So the molecular space, if the molecular spacing is larger than the solids, that you can call as a liquids. In case of gases, the molecular spaces between the molecular space between the particles is very large in cases of gases. So in this study we are going in this topic fluid mechanics, first we are going to discuss about the liquids, that means both gases and liquids and gases. So majorly in the fluid mechanics we are discussing more about the liquids. So how you can differentiate between the liquid and the gases. So it is so first property of the liquid is the first property of the liquid is it is difficult to compress. So we cannot compress the liquids. Actually liquids are we will assume liquids as incompressible, but there is a compressibility of the liquid, but that is very small. That's why we will assume it is incompressible. It is very difficult to compress the liquids. That's why we can call it as a incompressible. But in natural the liquids are compressible, but the compressibility is very small, that we may not be considered into account. So when it comes to the gases, it is easily compressed. So it changes its volume is very large. For example, if you take a balloon, gas in the balloon, if you release it into the room, it can occupy the room, occupy the space of the entire room. So if the balloon, if you apply the pressure, so it will be compressed. So you can reduce the huge balloon to small balloon, so you can apply the compressibility. So liquids, gases are compressible, so cannot normally neglected, and they are generally related to the temperature. So the compressibility we cannot neglect it in case of gases, but the compressibility effect in case of liquids is we can neglect because it is very small. So that's why liquids are incompressible. So second property is the liquids occupies a fixed volume. So the volume of the liquids may not change. So if you pour the liquid into the container, it will occupy the shape of the container. If you pour the liquid into anywhere, so it will occupy the shape of that particular container. So the volume is fixed. But in case of gases, the volume is not fixed, it will change. So if you apply the pressure, when the gas is filled with some vessel, and if you apply, so it will change its volume. So it changes volume to expand to fill the container and vessel. So you can compress, and if you release the same gas into the large room, so it can occupy the entire room. And so there is no fixed volume for the gases. But the liquids, there is a fixed volume for the gases. And also the liquids have the free surface. For example, if you pour the liquid into a container, and for example the capacity of this container is 2 liters, and if you pour 1 liter of water, so it can create the free space, free surface. So this is called free surface. So you can create the free surface. But in case of gases, so it can fill the complete vessel. There is no free surface in case of gases. For example, there is a container which is a volume of 1 meter cube, and if you pour the gas into this container, so it will occupy the entire container. So it will not left any empty space. So there is no free surface formed in case of gases, and there is a free surface formed in case of liquids. So these are the important properties. Based on that characteristics, based on that we can differentiate between the liquid and gas. So what is fluid? Before going to the fluid mechanics, first we'll try to understand what is the fluid. So what is fluid? Fluid is a substance that deforms continuously in the application of the tangential or shear stress. So if you apply a small amount of, irrespective of the force, irrespective of the stress or magnitude of the stress acting on the fluid, it will start continuously deforming until the force exacted on the fluid. So fluid is a substance that continuously deforms. So that you can call as a fluid. So even though if you apply a small magnitude of the force, it's trying to deform. So in the fluid mechanics, so what is fluid mechanics? Fluid mechanics is a branch of science which generally deals with the behavior of the fluid. So fluid mechanics is a branch of the science which deals with the behavior of the fluids. So we will try to understand the behavior of the fluid when the fluid at rest, at the same time as well as in motion. So while the fluid at rest and also when the fluid in motion, we will try to understand the behavior of the fluids in different conditions. What are the branch of science which deals with these behavior of the fluids at rest and motion, that you can call as a fluid mechanics. So in the fluid mechanics, we will try to understand mostly about the fluid means liquids and gases. We will try to understand the basic properties of the fluid, liquids like surface tension, vapor pressure, viscosity, density, compressibility, weight, and specific weight and specific volume. And also we will try to understand the fluid statistics, that means a fluid at rest condition, that is the stability conditions, pressure and buoyancy conditions, and also next we will try to understand the fluid dynamics. So we will consider the forces, consider the motion acting on the fluid while it is flowing. So in this fluid dynamics, we will try to understand the laminar and turbulent flows, and viscous and non-viscous fluids, and compressibility, incompressible, and also steady and unsteady flow conditions. This is the overview of the fluid mechanics. So majorly in the fluid mechanics, we will try to understand fluid statistics and fluid kinematics and fluid dynamics, that in detail we will discuss in the coming chapters. So normally we already discussed the fluid mechanics is categorized into 3 branches. One is fluid statistics, fluid kinematics, and fluid dynamics. In the fluid statics, we were trying to understand the fluid at rest. So we will study the characteristics of the fluid while it is at rest. What is meant by fluid at rest? Fluid at rest means there can be no shear force acting on it. So there is no shear force acting on the fluid. So therefore there is no shear force acting on the fluid. That means the fluid at rest. And one of the important assumption is all the fluid forces must be perpendicular to the plane upon which they act. For example, there is a fluid particle, and if you see, I have considered one fluid particles. What are the force acting on the fluid which is act normal to the surface? At any point it will act normal to the surface. So therefore all the forces must be perpendicular to the plane which they upon act. So what are the force acting on the fluid which is acting normal to the surface? The only stress in the fluid statistics is normal stress. So when the fluid at rest, we will consider only normal stresses acting on the fluid. We will not consider any other stresses, and there is no shear force acting on the fluid. So these are the conditions for the fluid statistics, or when you are studying the fluid properties when the fluid at rest. And second one is fluid kinematics. So in the fluid kinematics, we will try to study the motion of the fluid where pressure forces are not considered. So we will try to understand the fluid motion, or we will try to understand the characteristics of the fluid motion without considering the force acting on the fluid, without considering the force acting on the fluid or pressure acting on the fluid. So third is fluid dynamics. In the fluid dynamics, we will try to understand the fluid characteristics by considering the forces causing the motion. So here we will consider what are the forces causing the motion. So again I will quickly revise. In fluid statistics, we will try to understand fluid at rest. We will try to understand the fluid at rest conditions. So at the fluid at rest conditions, there is no shear forces acting, only normal stresses acting on the fluid. So we will consider the pressure force acting perpendicular to the surface. So in the second, we will fluid kinematics, we will try to understand the fluid motion without considering the force causing the motion. In the fluid dynamics, we will try to understand the fluid motions by accounting the force causing the motion. These are some of the applications of fluid mechanics in civil engineering. We already discussed in the introduction section. So here the majorly we will to design any hydraulic structures, including dams, spillways, or water bearing structures, or whatever, any hydraulic structures. So you have to use the fluid mechanics is very helpful to understand the amount of the flow is coming and what pressure is acting on the various components of the structure, and also it helps in designing the water and oil pipe networks, and also it is used to study the water and air pollution. So to model the air and water pollution, so we will use fluid mechanics, and also it is used to design the bridges across the rivers, and also to study the coastal engineering and oceanography and inshore infrastructure. This slide is already discussed. Yeah. So fluid property. Now we are going to the first topic, properties of the fluids. So what is property? So any characteristic of a system. So what are the characteristics of a system? Any characteristics of the system you can call as a property. So some well familiar properties of the systems are pressure. We already know, we will mostly every time we will discuss about the pressure, and also temperature and volume and mass. So these are the most familiar properties of the system: pressure, temperature, volume and mass. And other less familiar properties are viscosity and thermal conductivity, modulus of elasticity, thermal expansion coefficient, electric resistivity, and velocity and elevation. These are also some of the properties, and which we may not use regular purposes. And so the properties we can classify it into two categories. One is intensive and extensive properties. So what is intensive property and what is extensive properties? So intensive properties are those that are independent of the mass of the system. So what are the properties which are independent of the mass of the system, that you can call as a intensive properties. For example, temperature, pressure and density. We will discuss in detail. And next, extensive properties. What is extensive property? The extensive properties are those whose values depend on the size, extent of the system, or depends upon the mass of the system, or size, extent of the system. That is called extensive properties. For example, total mass, total volume, or total momentum are some of the examples of extensive properties. So again I will quickly revise. So any characteristics of the system you can call as a property. For example, familiar properties like pressure, volume, temperature and mass, these are some of the examples of familiar properties. And viscosity, velocity, thermal modulus of elasticity, etc. Some examples of the less familiar properties. So these properties can be classified into two categories. One is intensive and second one is extensive properties. The intensive properties are independent of the mass of the system, like pressure, temperature, volume, pressure, temperature, density, etc. And extensive properties are depends upon the size and extent of the system. For example, total mass, total volume, and total momentum, etc. So how you can say it is intensive properties and extensive properties. So for determination of the intensive and extensive properties is very easy, that we can do by so it is very easy to determine whether the property is intensive or extensive. So it is done by using, if you take any system, if you divide the system into two equal parts. So if you find the properties, whatever the properties you are looking for, the properties are same in both either halves, then you can call it as the intensive properties. If the properties are varies, if you divide it into two halves, then that is called as the extensive properties. For example, if you see, so mass, volume, temperature, pressure, and density, these are the 5 properties I have considered. I have taken one block and have divided into two halves. So here the mass became half mass and volume became half volume, and temperature, pressure, and density remain the same. There is no change in temperature and pressure and density. That's why this temperature and pressure and density you can call as the intensive properties. Whatever the mass and volume, these are depends upon the mass of the system. So that's why you can call as the extensive properties. So this is the way we can classify whether it is the identify the properties, whether it is intensive properties or extensive properties. Now we are trying to understand some of the fluid properties. What are the main fluid properties we are going to discuss in the coming chapter, lectures? One is density. One is density and specific weight. Yeah. Properties of the fluids. So some of the fluid properties we are going to deal with coming lectures is density. Density is nothing but the mass occupied by the fluid per unit volume, and specific weight, specific volume, specific gravity, dynamic and kinematic viscosity, surface tension, and capillarity. These are the 7 properties we are going to deal with the coming lectures. The first 4 properties I am going to cover in the first lecture, lecture 1. So what is density or a mass density? So density or a specific mass. Yeah. So density or mass density, or you can call it as a specific mass. It is nothing but the mass occupied per unit volume. How much mass occupied by the body per unit volume. So that you can call as a density. The units are, mass is represented in kg and volume in meter cube. That's why units are kg per meter cube, and sometimes you can represent it gram per centimeter cube, depends upon your interest. So these are the units. So the density is the mass occupied by the fluid per unit volume. So actually it depends upon the temperature and pressure. With increase of temperature, the volume of the fluid increases. So what happens if the volume of the fluid increases? If temperature increases, volume of the fluid increases. So that's why density is decreases. So density inversely proportional to volume. If the volume is decreases, density will increase. If the volume is increases, so the density will decrease. So pressure. So what happens if you increase the pressure? If the pressure is more, if you increase the pressure, the volume is decreases. If the volume is decreases, then density is increases. The density of water is 1000 kg per meter cube. in most of the fluid mechanics problem, they will not give the density of the fluid in the problems. So he will mention the water is flowing, or whatever the liquid is using is water. So then you have to assume this value. The density of the water is 1000 kg for meter cube. And also you have to know the density of mercury, and which is used in pressure measurement problems. So the density of the mercury is 13,600 kg per meter cube. So these are the two things you have to remember. And which may not be given in your most of the problems. They will mention the mercury is used, the water is used. Then you have to assume the density of the water is 1000 kg per meter cube, and the density of the mercury is 13,600 kg per meter cube. So again I will revise. Density means the mass occupied by the fluid per unit volume. Units are kg per meter cube. If you see here, the honey have higher density. Yeah. If you see here, these are some of the fluids which there are different densities. If you see, the water density is 1000 kg per meter cube, and the ice and vegetable oil have 900 kg per meter cube. And see, honey density is 1400 kg per meter cube. The density of the mercury is 13,600, and corn soap is 1370 kg per meter cube. If you pour all the fluids into the one container, so the density have higher density. That's why honey has higher density. That's why it settle at the bottom. And then vegetable have least density in all the materials, so it will float on the surface. So based on the density, they will occupy, like vegetation oil and water and dish soap and corn syrup and honey. Anyway, we will discuss these properties in detail in the coming chapters. The second fluid property is weight density or specific weight. Second fluid property is weight density or specific weight. So what is meant by weight density or specific weight? It is the weight per unit volume. So the weight of the fluid occupied per unit volume. So it is nothing but the weight by unit volume. So units, weight is newtons and volume in meter cube. So it is Newton per meter cube. So it depends upon the temperature and pressure. If the temperature increases, volume increases. The volume increases, hence specific weight decreases, similar to the density. If the pressure increases, volume decreases. The pressure increases, volume decreases. So specific weight will decrease. Oh, sorry. I think weight. Yeah. Okay, weight density or specific weight. So the second fluid property is weight density or specific weight. It is nothing but the weight of the fluid occupied per unit volume. How much weight the fluid occupies per unit volume, that is weight density. The units are So units of weight is Newton and volume is meter cube. So units are Newton per meter cube. It also depends upon temperature and pressure. So if increase of temperature, the temperature increases, volume increases, the volume increases and specific weight decreases. So if the pressure increases, volume decreases. If the volume decreases, specific weight increases. Specific weight increases. So what is the relation between the mass density and weight? So we know weight is equal to mass into acceleration due to gravity, right? So density is equal to mass by volume. Density is equal to mass by volume. So mass is equal to density into volume. So if you replace this equation 2 in 1, so weight equal to rho V into G, that means rho G V. Rho G V. So this is the weight. The specific weight is weight by volume, that means rho G V by V. V cancel. The specific weight is rho into G. So this is the relationship between the specific weight and mass density. So W is equal to rho into G. The third fluid properties we are trying to understand is specific gravity or relative density. The specific gravity or relative density is nothing but the density. It is the ratio of density of the fluid by density of the standard fluid. Density of the fluid by density of the standard fluid. So we will consider for liquids. The third fluid properties is specific gravity or relative density, which is nothing but the ratio of density of the fluid by density of the standard fluid. So it is the ratio of density of the fluid by density of the standard fluid. For liquids, we will consider water as a standard fluid. So water as a standard fluid, that means it is 1000 kg per meter cube. For gases, we will consider air as a standard fluid or standard gas. So that will be, the density is 1.23 kg per meter cube. So the standard liquid is water, that is 1000 kg per meter cube. For gas, it is 1.23 kg per meter cube. So it is a dimensionless quantity. Why? Because it is a density is kg per meter cube by kg per meter cube. So they will cancel each other. So there is no dimension, that's why there is no units. So in case of liquid, we will consider the density of the standard fluid is 1000 kg per meter cube. For air, for gases, we will take 1.23 kg per meter cube. These things you have to remember to solve some numerical problems. The fourth property of the fluid is specific volume. The fourth property of the fluid is specific volume. The specific volume is nothing but it's a volume per unit mass. So for unit mass, how much volume occupied by the fluid? This is a volume per unit mass of the fluid. So per unit mass, how much volume it occupies? So units are volume units meter cube and mass kg. So it is a meter cube by kg. So it is also depends upon temperature and pressure. If the temperature increases, volume increases and hence specific volume increases. The temperature increases, volume increases, so specific volume increases because it is directly proportional. And if the pressure increases, volume decreases, so specific volume decreases. So temperature and pressure also influence specific volume. Now we will try to solve few numerical problems related to fluid properties, whatever we have discussed so far. So the question is, calculate the specific weight. So you have to calculate the specific weight. You have to calculate the specific weight, density and specific gravity of the fluid, of the liquid which weighs 7 newtons. So to solve any numerical problems, first we will try to identify the given variables. So what is given? Weight. So weight is given is 7 newtons. So what you have to find out? Specific weight, you have to find out density, you have to find out specific gravity, you need to find out. These are the three variables you need to find out. Only given variable is weight. So then we need to know the relationship between the known and unknown variables. What is known variable? Weight. So unknown variables omega, rho and s, right? So what is mu? Specific weight formula. Specific weight is equal to weight by volume, and density is equal to mass by volume, and specific weight is equal to, specific gravity is density of the fluid by density of the standard fluid. But we know only weight, so we don't know and one more variable is given, 1 liter of liquid, 1 liter of liquid, that means volume is given. So this is in liters, but normally how we will use volume? In meter cube. So we need to convert this liters into meter cube. How we are going to convert? So we know that 1000 liters will occupy 1 meter cube volume. 1000 liters, so 1 meter cube of container can have 1000 liters of water. 1000 liters of water. So here the weight, the volume of the liquid is given as 1 liter. So that means volume is 1 by 1000 meter cube. That means 0.001 meter cube. Now we know the volume, we know, and weight we know. So we know the weight and volume, so we can calculate the specific weight. So that means specific weight omega will be weight by volume. So the weight will be 7 and volume is 0.001, that is 7. So that is 7000 Newton per meter cube. Now we know the specific weight of the fluid. The specific weight of the fluid is 7000 Newton per meter cube. Units are very important. Okay. Now we will try to find out the second variable, density. So the density is formula mass by volume. So what is the mass? We don't know, but we know the weight, 7 newtons. So we know the relationship, weight is equal to mass into acceleration due to gravity. So we know, so mass is equal to weight by g. That means weight is given as 7 newtons and acceleration due to gravity you can assume as 9.81. 9.81. So this is the mass. So if you substitute these values, we already calculated the specific weight, that is 1000 Newton per meter cube. Next we need to find out the density. So we know the relation between the specific weight and density. Specific weight is equal to rho into g. So what about the density? Density rho is equal to specific weight by g. The specific weight is 7000 divided by 9.81. So that means is 713.57 kg per meter cube. So this is the density of the given fluid. So next we need to find out the specific gravity. Specific gravity of the liquid. What are the liquid given in the problem? The specific gravity is nothing but the ratio of density of the fluid or density of the liquid by density of the standard fluid or standard liquid. So here the mention liters of liquid. We need to find out specific gravity of the liquid. So this we need to find out. right? Specific gravity, okay, that we need to find out. So we know the density of the fluid. So S is density of the fluid, density of the liquid by density of the standard liquid. So it is here he mentioned it is a liquid. So we can assume the density of the standard liquid as 1000 kg per meter cube. This is the density of the standard liquid. So density of the liquid is given as 713.57. So density of the standard liquid is 1000. So that is 0.713. So this is the specific gravity of the liquid. Now we will try to solve. Okay. Now we will try to solve another numerical example. Yeah. So you have to calculate. Yeah. Second problem we are trying to solve. You have to calculate the specific weight and density and weight of 1 liter of petrol with specific gravity is 0.7. With specific gravity is 0.7. So what is the variables are given? Yes, specific gravity of the liquid is given 0.7 and volume of the liquid is given 1 liter of petrol. So volume of the petrol is 1 liter. That means we already calculated 1 divided by 1000, 0.001 meter cube. This is the volume of the petrol. So you have to calculate the specific weight, density and weight. So what is the relationship? Specific weight. Specific weight, W is equal to weight by volume. So volume we know, weight we don't know, so we cannot calculate the specific weight directly now. Density is mass by volume. Volume we know, but mass we don't know, so we cannot calculate density also. So S is given density of the fluid by density of the, you can say liquid, density of the liquid by density of the standard liquid. So density of the fluid is not given, right? Yeah, density of the fluid is not given. So this we don't know. Density of the fluid is not given, but he mentioned it is a petrol, that means liquid. So we can assume as density of the standard fluid. Density of the standard fluid as 1000 kg per meter cube. 1000 kg per meter cube. That means this we know, and specific gravity is given 0.7. So you can calculate the density of the fluid. That means 0.7 equal to density of the fluid by 1000. That means density of the fluid is 700 kg per meter cube. Now you know the density of the fluid and you know the volume, so you can calculate the density, right? So rho, you know, rho is equal to m by v. So rho is how much? 700 kg per meter cube. That means mass. What is the mass? That you need to find out. By volume you know 0.01. So this is 700. So what is the mass? So then mass is 7 kg. So mass is 0.7 kg. Yeah, the mass is 0.7 kg. Now we know the mass. So mass is 0.7 kg. So we calculated the density. So mass we know. So how we can calculate the weight? So weight is equal to m into g. That means 0.7 into 9.81 is 6.87 newtons. So the weight of the liquid is 6.87 newtons. So we need to calculate the specific weight. So we know specific weight is weight by volume. So weight we know 6.87 and volume we know 0.01. That means specific weight is 6870 Newton per meter cube. So this is the specific weight, and density of the fluid and you need to find out the weight. So weight of the fluid. Similarly, you can solve any other numerical related to fluid properties. So thank you for your attention, and if you have any queries, you can contact me through mail. So my mail ID is ch. So thank you for your attention, and if you have any queries, you can contact me through mail. My mail ID is ch.tirupati1@shashi.ac.in. So with this, we are going to close the lecture 1, and next class we will discuss about the other properties like viscosity, dynamic viscosity, kinematic viscosity, surface tension and capillarity and other things. Thank you. I can.